Oh, welcome. In this video, I'm going to review two methods for solving quadratics. When to factor and when you can use the square root method. Okay? For our class, you're going to be able to factor anything that has an x squared and an x. If it has an x squared term and an x term in our class, then you'll be able to factor it. If it has only an x squared term, you don't see an x term, just an x squared term, then you can use the square root method, unless I tell you to use difference of squares. Okay? So read the instructions. Let's look at this problem. And you might be telling yourself, I don't see an x squared anywhere here. Okay? But I do see two x's, don't I? And I surely don't see just one x squared. Let's see what happens if we expand. You want to expand this because when you're factoring, you know the quadratic must equal 0. Here we see some sort of factoring going on. We see two things being multiplied, but it doesn't equal 0. So let's see what happens when we distribute this 2x. We get 2x squared plus 8x equals 120. And now you can see your x squared and your x term. So yeah, we're going to go ahead and factor this. Let's make sure it equals 0. Subtract 120 on both sides. Rewrite 2x squared plus 8x minus 120 equals 0. These numbers are kind of big. If we're going to multiply a and c to factor, we're going to get 240. There's a lot of factors, 240. But I do notice these are all even. So let me go ahead and factor out a 2. If I divide all of these terms by 2, and I can factor a 2 outside, reverse distribute, and I get x squared plus 4x minus 60 equals 0. And now I can just factor this. Notice inside the parentheses here, the coefficient on x squared is just 1, so we can use our shortcut. Let's find two numbers that multiply to negative 60, that also add to positive 4. And you probably got it in your mind already. We're going to use 6 and 10. Let's take a look at which one has to be negative. Because we have a negative product, we need a negative number to multiply with a positive number. But we also need a positive sum. So if we're going to add a positive and a negative and get a positive sum, the larger number has to be positive. Now it's starting to make sense. Negative 6 plus positive 10 equals 4. And negative 6 times 10 is negative 60. So we know that this is going to equal 2 times x minus 6 times x plus 10 equals 0. So now we can use the zero product property. By the zero product property, we can say that x minus 6 equals 0, in which case adding 6 to both sides shows us that x equals 6. Or, our other factor is x plus 10 equals 0, in which case x equals negative 10. Why? Well, we would subtract 10 from both sides and get x equals negative 10. Awesome. So that's how you factor, and this is what you want to look for. Notice, does it equal 0? No. So let me distribute these factors. When I distribute these factors, now I can make it equal 0. See if there's a common GCF you can factor out. That makes factoring the quadratic a little bit easier, and we're able to finish up very nicely. And these are our two solutions. So using the square root method, I see just one x squared. This is a constant term. This is a constant term. Awesome. So what are we going to do? Well, use SADMAP. What is SADMAP? Well, it's PEMDAS backwards. We want to isolate the variable. We want to isolate x. We want to unwrap it. We want to get rid of all these numbers around x so we know x equals one number. So I see a minus 33. I see a times 4. Using SADMAP, I want to undo this subtraction first because we're going to go in this direction. How do I undo subtraction? Using inverse operations. So I'm going to add 33 to both sides. That cancels. When I add 33 to the right here, I get 100. So 4x squared equals 100. We're trying to isolate x, so let's see what's on x. I see x times 4. X is also squared. So let's consult SADMAP to see what we need to do next. Multiplication comes before exponents, so let's undo this multiplication. The inverse of multiplying is dividing. So if I divide by 4 on both sides, that will cancel with my multiplying by 4. I can then rewrite x squared equals 25. Okay. I want to get rid of the square, so you got to square root it to cancel with the square. When you square root it, don't forget the plus or minus. Excellent. Excellent. So x is equal to, square root of 25 is 5, positive or negative 5. Excellent. Alright, so that's how you use the square root method. I also thought you might appreciate if we did a word problem. So, if I erase the board here real quick, and I had a word problem that said something like 3 consecutive odd integers have a sum of squares that is equal to 155. What are the integers? What are they? Well, let's think about that. What does it mean to be consecutive, one after the other? The numbers 1 and 2 and 3 are consecutive. 1 and 2 and 3. The next consecutive integer would be 4. The next consecutive integer would be 5. They're talking about consecutive odd integers, so let's just make a list of our odd integers. 1, 3, 5, 7, 9, 11. Okay, so 3 consecutive odd integers that are next to each other. Notice how these are all separated by 2. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. So we can use this property for consecutive odd integers. Alright, so we can just start with our first one and call it x. We would also have the next consecutive odd integer as x plus 2. And then the next consecutive integer, we would add another 2 to this. So x plus 2 is x plus 4. Awesome. So let's set up our equation. We would have the sum of their squares. So x squared plus x plus 2 in parentheses squared, because this is a number, x plus 2. And we're going to add to that the square of this number, x plus 4. Now, we know how to deal with a binomial squared. We have to use the box method. We're going to have to do that twice here. We know that this is equal to 155, so I don't want to forget that. So let's just use the box method and expand these, and then we'll condense it all down to ax squared plus bx plus c equals 0. and we'll be able to factor it. Okay? So x squared plus, if I multiply this out, I get x squared plus 4x plus 4. That's this binomial expanded right here. Plus, if I expand this, we get x squared plus 8x plus 16, and this is all equal to 155. Once again, if you use the box method or the FOIL method to expand this, you get this right here. So now let's just combine all of our like terms. I have 1, 2, 3x squareds. How many x's do I have? Well, I have 4 here and 8 here. So that's going to be 12 x's. And how about my numbers? Well, 4 and 16 equals 20. So plus 20. And this is going to equal 155. So that wasn't too hard. We have to make this equal 0, so that way we can factor and use the zero product property. Remember, you can't use the zero product property unless you have it equaling 0. So let me just go ahead and subtract 155 from both sides. Okay, so I'll work over here. And what we get is 3x squared plus 12x. Alright, now 20 and negative 155 is going to be negative 135. So minus 135 equals 0. I know these two are divisible by 3. This is also divisible by 3. There's a little trick actually. If you add the digits and that sum is divisible by 3, you know the number is divisible by 3. Check it out. 1 plus 3 plus 5 is 9. 9 is divisible by 3, so this is divisible by 3. Pretty cool. Alright, so let's factor out that 3. I'll have x squared left inside. Right, remember when I'm factoring, I'm just reverse distributing. So I want to divide all of these by 3, write the 3 on the outside, and then continue with what I factored after I factor out the 3, what I have inside the parentheses. So x squared plus 4x minus, still a little bit of long division, yeah? 135 divided by 3, what do we get? 3 goes into 13 4 times, that's going to give us 12. Subtract 1, 15. 3 goes into 15 5 times, so we have 45 equals 0. Awesome. Now a is 1 inside here, so I can use my shortcut. What two numbers multiply to negative 45 that add to positive 4? Let's see, factors of 45. Let's make a list. I'm going to make a list right here. So I know that 45 is 5 times 9, and it looks like that's going to be it. Don't those numbers have a difference of 4? Yes. Okay? So let's figure out which one has to be positive and which one has to be negative, because I have a negative product. One of these has to be positive and one has to be negative. 5 and 9, but I want them to add to be positive 4, so that means I have a negative 5 and a positive 9. The sign of your middle coefficient is always the sign of the larger number. Excellent. So now I know I can go straight to my factors, which are 3 times x minus 5 times x plus 9. This all equals 0. So x will equal, if x minus 5 equals 0, right? Remember we use the zero product property. let me not skip that step. By the zero product property, I know x minus 5 equals 0, so that means if I add 5 to both sides, awesome, x is 5. Also, x plus 9 equals 0, so subtracting 9 from both sides, I get negative 9. X equals negative 9. So let's answer this question. What are the integers? Well, if x is 5, I can erase some of this work. If x is 5, then I'll have 5. 5 plus 2 is 7. 7 plus 4 is 9. Awesome. What if x is negative 9? Well, what's negative 9 plus 2? Well, since it's negative and we're adding, we're going to get negative 7. Negative 9 plus 4, because x is negative 9 here, we get negative 5. So these are our two solution sets. Positive and negative, 5, 7, and 9. Okay. Excellent. Thank you very much for watching. I hope this helps. If you have any questions, you can